Hey everyone, welcome back. Tonight, we're doing something a little different. We're talking about eyes. Specifically, your eyes. The color you were born with, the shade you see every morning in the mirror, and all the hidden advantages you probably never knew came with it. Before we dive in, if you're enjoying this kind of content, go ahead and hit that like button. Subscribe if you want more of these deep dives into biology, history, and the strange truths about being human. And drop a comment telling me your eye color and where you're watching from. I'm genuinely curious to see the spectrum we've got here tonight. Now, get comfortable, adjust your pillow, dim those lights, maybe let a fan hum softly in the background. Because what we're about to explore isn't just trivia. It's genetics, evolution, adaptation, and survival. It's the story of how a simple pigment in your iris gave your ancestors advantages you're still carrying today. Some eye colors see better in certain light, some resist specific diseases, some even change how others perceive you before you say a single word. Whether your eyes are brown, blue, green, hazel, gray, or something rare and in between, tonight you'll learn what makes them special, what they can do that other colors can't, and why evolution decided you'd be born with exactly the shade you have. Let's begin with the most common eye color on Earth, the one that belongs to roughly 80% of humanity. Let's talk about brown eyes. If you have brown eyes, you're part of the vast majority. Walk down any street in Asia, Africa, South America, or the Middle East, and nearly every face you pass will have them. Brown eyes aren't just common, they're the original blueprint, the default setting that humans carried out of Africa tens of thousands of years ago when our species first began its long journey across the planet. The reason brown eyes dominate comes down to a single molecule, melanin. It's the same pigment that colors your skin and hair, and in your eyes, it's packed densely into the iris. The more melanin you have, the darker your eyes appear. Brown-eyed people have high concentrations of melanin in both the front and back layers of the iris, creating that deep, rich color that ranges from light amber brown to nearly black. But melanin isn't just about aesthetics. It's a shield, a biological defense system that's been protecting human eyes for millennia. And if you were born with brown eyes, you inherited one of evolution's most practical advantages: superior protection against ultraviolet radiation. UV rays from the sun are relentless. They penetrate the atmosphere, bounce off surfaces, and bombard our bodies every single day. For the eyes, this exposure can be devastating over time. UV radiation damages the delicate structures inside the eye, particularly the lens and the retina. It accelerates the breakdown of proteins, clouds the lens, and destroys light-sensitive cells. Over decades, this damage accumulates into serious conditions: cataracts, macular degeneration, even certain types of eye cancer. Brown eyes, with their high melanin content, absorb and scatter much of this harmful radiation before it reaches the vulnerable inner structures. Think of melanin as a built-in pair of sunglasses, permanently installed. Studies have shown that people with dark brown eyes have significantly lower rates of age-related macular degeneration compared to those with lighter eyes. They also develop cataracts later in life, if at all. The protection is measurable, significant, and lifelong. This advantage wasn't random. It was carved into our DNA by natural selection. Our earliest human ancestors lived near the equator, where the sun's rays strike most directly and UV exposure is at its peak. In that environment, having more melanin in your eyes wasn't just helpful, it was essential. Those with darker eyes could hunt, gather, and survive longer without their vision deteriorating. They passed those genes forward, and brown eyes became the norm. But melanin does more than block UV light. It also enhances visual contrast in bright conditions. When sunlight is intense, lighter-colored eyes can become overwhelmed. The lack of pigment means more light enters the eye, scattering and creating glare. Brown-eyed individuals, however, experience less internal scattering. The melanin absorbs excess light, sharpening the image and reducing that washed-out, squinting sensation that comes with stepping into harsh daylight. This is why brown eyes are still so common in regions near the equator. From sub-Saharan Africa to India, from Southeast Asia to Central and South America, populations that have lived for generations under intense sunlight have retained high melanin levels in their eyes. It's an adaptation written into their biology, a survival tool passed down through countless generations. There's also something fascinating about how brown eyes age. While lighter eyes often become more sensitive to light over time and may develop visible cloudiness or discoloration, brown eyes tend to maintain their structural integrity longer. The melanin continues to do its job, protecting the eye's interior even as the body grows older. This doesn't mean brown-eyed people are immune to vision problems, but statistically, they face fewer of the specific conditions caused by cumulative UV damage. And then there's the psychological side. Brown eyes are perceived differently across cultures. In many societies, they're associated with warmth, trustworthiness, and reliability. Studies on facial perception have shown that people with darker eyes are often judged as more approachable and dependable, though these are social constructs rather than biological truths. Still, perception shapes interaction, and interaction shapes survival, especially in our deeply social species. But here's where the story gets interesting. Brown eyes, for all their dominance and advantages, weren't the end of the evolutionary road. Because as humans migrated out of Africa and spread across the globe, they encountered new environments, places where the sun barely rose for half the year, where the light was dim, diffuse, and scarce. And in those places, a mutation occurred. A tiny genetic accident that would change the color of human eyes forever and create advantages that brown eyes simply couldn't provide. If you have brown eyes, you're part of the vast majority. Walk down any street in Asia, Africa, South America, or the Middle East, and nearly every face you pass will have them. Brown eyes aren't just common, they're the original blueprint, the default setting that humans carried out of Africa tens of thousands of years ago, when our species first began its long journey across the planet. The reason brown eyes dominate comes down to a single molecule, melanin. It's the same pigment that colors your skin and hair, and in your eyes, it's packed densely into the iris. The more melanin you have, the darker your eyes appear. Brown-eyed people have high concentrations of melanin in both the front and back layers of the iris, creating that deep, rich color that ranges from light amber brown to nearly black. But melanin isn't just about aesthetics. It's a shield, a biological defense system that's been protecting human eyes for millennia. And if you were born with brown eyes, you inherited one of evolution's most practical advantages: superior protection against ultraviolet radiation. UV rays from the sun are relentless. They penetrate the atmosphere, bounce off surfaces, and bombard our bodies every single day. For the eyes, this exposure can be devastating over time. UV radiation damages the delicate structures inside the eye, particularly the lens and the retina. It accelerates the breakdown of proteins, clouds the lens, and destroys light-sensitive cells. Over decades, this damage accumulates into serious conditions: cataracts, macular degeneration, even certain types of eye cancer. Brown eyes, with their high melanin content, absorb and scatter much of this harmful radiation before it reaches the vulnerable inner structures. Think of melanin as a built-in pair of sunglasses, permanently installed. Studies have shown that people with dark brown eyes have significantly lower rates of age-related macular degeneration compared to those with lighter eyes. They also develop cataracts later in life, if at all. The protection is measurable, significant, and lifelong. This advantage wasn't random. It was carved into our DNA by natural selection. Our earliest human ancestors lived near the equator, where the sun's rays strike most directly and UV exposure is at its peak. In that environment, having more melanin in your eyes wasn't just helpful, it was essential. Those with darker eyes could hunt, gather, and survive longer without their vision deteriorating. They passed those genes forward, and brown eyes became the norm. But melanin does more than block UV light. It also enhances visual contrast in bright conditions. When sunlight is intense, lighter-colored eyes can become overwhelmed. The lack of pigment means more light enters the eye, scattering and creating glare. Brown-eyed individuals, however, experience less internal scattering. The melanin absorbs excess light, sharpening the image and reducing that washed-out, squinting sensation that comes with stepping into harsh daylight. This is why brown eyes are still so common in regions near the equator. From sub-Saharan Africa to India, from Southeast Asia to Central and South America, populations that have lived for generations under intense sunlight have retained high melanin levels in their eyes. It's an adaptation written into their biology, a survival tool passed down through countless generations. There's also something fascinating about how brown eyes age. While lighter eyes often become more sensitive to light over time and may develop visible cloudiness or discoloration, brown eyes tend to maintain their structural integrity longer. The melanin continues to do its job, protecting the eye's interior even as the body grows older. This doesn't mean brown-eyed people are immune to vision problems, but statistically, they face fewer of the specific conditions caused by cumulative UV damage. And then there's the psychological side. Brown eyes are perceived differently across cultures. In many societies, they're associated with warmth, trustworthiness, and reliability. Studies on facial perception have shown that people with darker eyes are often judged as more approachable and dependable, though these are social constructs rather than biological truths. Still, perception shapes interaction, and interaction shapes survival, especially in our deeply social species. Consider this. If you were an early human living in a tight-knit tribal group, being perceived as trustworthy could mean the difference between cooperation and conflict, between sharing resources and being left behind. Eye contact has always been fundamental to human communication, and the color framing that contact influences how messages are received. Brown eyes, being the ancestral norm, may have become the baseline against which other colors were unconsciously measured. There's also evidence suggesting that brown-eyed individuals may have a slight advantage in certain athletic activities, particularly those requiring performance in bright outdoor conditions. The reduced glare and better contrast perception can improve reaction times and spatial awareness when sunlight is a factor. It's a small edge, but in competitive scenarios or survival situations, small edges accumulate. But perhaps the most underappreciated advantage of brown eyes is their universality. Because they're so common, they blend seamlessly across cultures and geographies. In a world that's increasingly interconnected, where people migrate and cultures mix, brown eyes carry no exotic rarity, but also no burden of otherness. They're familiar everywhere, which, in evolutionary terms, means safety. Familiar features trigger less suspicion, more acceptance, easier social integration. The genetics behind brown eyes are relatively straightforward compared to other colors. The genes responsible, primarily OCA2 and HERC2, produce high levels of melanin when functioning in their dominant form. This is why brown eyes are considered genetically dominant. If you inherit even one brown eye gene from a parent, there's a strong chance you'll have brown eyes yourself. The trait pushes through, asserting itself generation after generation. And yet, despite their dominance, brown eyes haven't completely eliminated other eye colors from the human population. That's because evolution isn't about perfection. It's about adaptation to specific environments. And as humans spread into different climates and lighting conditions, new mutations offered different advantages. Advantages that, in certain contexts, outweighed the benefits of melanin-rich brown eyes. So if you have brown eyes, know this: you carry the original human eye color, the one that allowed our species to survive and thrive under the harshest sun. You have built-in UV protection, enhanced contrast in bright light, and a color that's been trusted and recognized for tens of thousands of years. Your eyes are a testament to endurance, adaptation, and the long, slow journey of human evolution. But what happens when humans migrate north, where the sun hides for months and the light becomes scarce and weak? That's where the story takes a dramatic turn, and a single genetic mutation changes everything. Somewhere around 10,000 years ago, near the Black Sea region, something extraordinary happened. A single human was born with a genetic mutation so subtle that it changed just one letter in their DNA. One tiny switch in the OCA2 gene, and suddenly, melanin production in the iris was disrupted. The result? Blue eyes. And here's the astonishing part. Every single blue-eyed person alive today, all of them, can trace their ancestry back to that one individual. Think about that for a moment. If you have blue eyes, you share a common ancestor with every other blue-eyed person on Earth. It's a genetic signature that's been passed down through hundreds of generations, spreading slowly across Europe and eventually the rest of the world. Blue eyes aren't just rare because they're recessive. They're rare because they're new, evolutionarily speaking. A recent innovation in the long history of human vision. But why did this mutation survive? Why didn't it disappear like countless other random genetic variations? Because in the environments where it emerged, blue eyes offered something brown eyes couldn't: superior vision in low light. When humans migrated into northern Europe, they encountered a radically different world. The sun hung low in the sky, often hidden behind clouds for days or weeks. Winters stretched long and dark, twilight lasted for hours. In these dim conditions, having less melanin in the iris became an advantage. Blue eyes allow more light to enter the eye because there's less pigment to absorb it. The iris acts less like a filter and more like an open window, letting in every available photon. This adaptation is called scotopic vision, the ability to see in low light conditions. Blue-eyed individuals have measurably better scotopic sensitivity than those with darker eyes. In twilight, in dense forests, in the dim interiors of shelters lit only by firelight, blue eyes could distinguish shapes and movement more effectively. For hunters tracking prey at dawn or dusk, for gatherers navigating through shadowed woods, this was a survival advantage worth keeping. There's also a theory, still debated but compelling, that blue eyes helped with vitamin D synthesis. In northern latitudes, sunlight is scarce, and the body struggles to produce enough vitamin D through the skin alone. Some researchers suggest that lighter eyes, along with lighter skin, were selected for because they allowed the body to maximize every bit of available sunlight. Less melanin meant more UV absorption, which meant better vitamin D production, which meant stronger bones, healthier immune systems, and better overall survival. But blue eyes come with trade-offs. That lack of melanin, so useful in the dark, becomes a liability in bright sunlight. Blue-eyed people are significantly more sensitive to glare. Step outside on a sunny day without sunglasses, and the world becomes an overexposed photograph. Light scatters inside the eye, creating halos around objects and reducing visual clarity. This is why blue-eyed individuals squint more, seek shade instinctively, and often feel genuine discomfort in intense brightness. The medical statistics reflect this vulnerability. Blue-eyed people have higher rates of certain eye conditions tied to UV exposure. Macular degeneration occurs more frequently. Cataracts can develop earlier. Melanoma of the eye, though rare, is more common in those with lighter irises. The very feature that helped their ancestors see in the dim forests of ancient Europe now makes their eyes more fragile under the modern sun. Yet blue eyes persisted and spread. By the time agriculture took hold in Europe, blue eyes had become common in northern populations. They moved westward into Scandinavia, the British Isles, and eventually across the Atlantic with European migration. Today, blue eyes are most prevalent in countries like Finland, Estonia, and Iceland, where up to 80 or even 90% of the population has them. It's a genetic echo of ancient adaptation, still visible in modern faces. There's another advantage to blue eyes that has nothing to do with biology and everything to do with perception. In many cultures, particularly Western ones, blue eyes are considered striking, unusual, and attractive. This isn't a universal preference. It's culturally constructed, but it's real enough to influence social dynamics. Throughout history, blue eyes have been romanticized in art, literature, and mythology. They've been described as icy, piercing, mysterious, ethereal. Whether this cultural attention provided any reproductive advantage is impossible to prove, but it certainly hasn't hurt the gene's spread. Interestingly, blue eyes aren't actually blue. There's no blue pigment in a blue iris. The color is an optical illusion, created by the way light scatters through the collagen fibers in the stroma, the front layer of the iris. It's the same phenomenon that makes the sky appear blue, Rayleigh scattering, shorter wavelengths of light, the blue end of the spectrum, scatter more than longer wavelengths. When light hits a blue iris, the red and yellow wavelengths are absorbed by the small amount of melanin present, while the blue wavelengths scatter and reflect back out. What you see is structure, not pigment. This is why blue eyes can appear to change shade depending on lighting, clothing, or even mood. They're not actually changing. The light interacting with them is. In bright light, they might look pale and icy. In dim light, darker and more gray. Against certain colors, they take on hints of green or violet. It's a shifting, dynamic color that responds to its environment in ways that brown eyes, dense with melanin, simply don't. One more fascinating detail. Blue-eyed babies aren't always born with blue eyes. Or rather, Many babies are born with blue or grayish eyes that later turn brown. This happens because melanin production in the iris doesn't fully kick in until several months after birth. The lack of melanin makes newborn eyes appear blue by default. But if the genes are set to produce melanin, the color will gradually shift over the first year or two of life. True blue eyes, the ones that stay blue, remain that way because the mutation prevents melanin from ever developing in the front layer of the iris. So if you have blue eyes, you carry a mutation that's only 10,000 years old. You see better in low light, you're more sensitive to glare, you have a higher risk of certain eye diseases, but also a genetic link to every other blue-eyed person on the planet. Your eyes are a reminder that evolution doesn't stop, that even in the brief span of human history, we continue to adapt. But blue isn't the only color that emerged from this northern shift. There's another eye color, rarer still, that occupies a strange middle ground between brown and blue. Let's talk about green. Green eyes are the rarest of the common eye colors. Only about 2% of the world's population has them. That's roughly 160 million people out of 8 billion. Walk through a crowded city and you might see a handful. Travel to certain parts of the world and you might not see any at all. Green eyes are a genetic lottery win, a combination of factors so specific that most people will never inherit them. The genetics behind green eyes are fascinatingly complex. Unlike brown or blue, which are primarily controlled by straightforward dominant or recessive genes, green eyes require a perfect storm of genetic conditions. You need a specific variant of the OCA2 gene, the same one involved in blue eyes, but with just enough melanin production to avoid pure blue. Then you need a second factor, lipochrome, a yellowish pigment that overlays the blue base created by light scattering. Blue plus yellow equals green. It's optical mixing, like watercolors bleeding into each other on paper. But getting that exact combination is tricky. Both parents need to carry the right recessive genes, and even then, there's no guarantee. 2 green-eyed parents can have a brown-eyed child. 2 brown-eyed parents can produce a green-eyed child if the recessive genes align perfectly. It's genetic roulette, and green is one of the hardest numbers to hit. Geographically, green eyes cluster in specific regions. Northern and Central Europe, particularly Ireland, Scotland, and Iceland, have the highest concentrations. In Ireland, up to 10 or even 15% of the population has green eyes, making it one of the few places where they're common enough to seem almost unremarkable. They also appear with some frequency in parts of the Middle East, particularly among populations with mixed European and Middle Eastern ancestry, but venture into East Asia, Sub-Saharan Africa, or most of the Americas, and green eyes are almost non-existent. So what advantages do green eyes offer? Interestingly, they occupy a middle ground between brown and blue, and that balance gives them a unique set of strengths. Green eyes have moderate melanin levels, more than blue but less than brown. This means they handle light better than blue eyes, but not quite as well as brown. They're less sensitive to glare than blue eyes, less prone to squinting in bright sunlight, but still more comfortable in lower light than brown eyes. Think of green eyes as the Goldilocks option. Not too much melanin, not too little. Just enough to filter harsh light without losing sensitivity in dim conditions. For someone living in a temperate climate with variable weather, cloudy mornings and bright afternoons, green eyes adapt reasonably well to both extremes. They're flexible, responsive to changing light in ways that purely dark or purely light eyes aren't. There's also evidence, though still being researched, that green-eyed individuals have slightly different patterns of disease resistance compared to both brown and blue. Some studies suggest they have lower rates of certain autoimmune conditions, though the mechanisms aren't fully understood. Others indicate that green eyes, like blue, carry higher risks for UV-related damage, but not quite as severe. The moderate melanin provides some protection, a buffer that blue eyes lack entirely. But perhaps the most interesting aspect of green eyes is their cultural mystique. Because they're so rare, they've been mythologized across civilizations. In ancient Greece and Rome, green eyes were associated with the supernatural, with witches and seers. In medieval Europe, they were sometimes seen as a mark of the otherworldly, something not quite human. Even today, green eyes carry an aura of uniqueness. They stand out in a way that brown eyes, for all their advantages, simply don't. This rarity can be a social advantage. Studies on attractiveness and mate selection have found that uncommon features often draw attention and interest. Green eyes, being unusual but not so rare as to seem alien, hit a sweet spot. They're distinctive enough to be memorable without being unsettling. In photographs, they catch light in complex ways, shifting between shades of emerald, jade, hazel green, and olive depending on the angle and illumination. And speaking of shifting, green eyes are notorious for appearing to change color. More than blue, more than hazel. Green eyes seem to transform based on what's around them. Wear a green shirt, and they intensify. Wear red, and they look more yellow-toned. Stand in natural sunlight versus artificial indoor light, and the difference can be dramatic. This happens because green eyes have such a delicate balance of pigments and scattering. Small changes in lighting or surrounding colors tip the optical balance one way or another. The yellowish lipochrome pigment in green eyes is particularly sensitive to contrast. When surrounded by warm colors, it becomes more visible, making the eyes look amber or hazel green. When surrounded by cool colors, the blue undertones dominate, shifting the appearance toward teal or blue-green. It's not magic, it's physics and biology working together, but it creates an effect that feels almost alive. There's also something worth noting about how green eyes age. Like blue eyes, they're more vulnerable to UV damage over a lifetime, which means green-eyed individuals need to be more vigilant about sun protection. Sunglasses aren't just a fashion choice, they're a medical necessity. But interestingly, because green eyes have some melanin, they don't develop the same degree of light sensitivity that blue eyes often do in later decades. The aging process is gentler, more gradual. Historically, green eyes have been both celebrated and feared. In Renaissance art, they were often given to figures of mystery or ambiguity, characters who weren't easily categorized. In literature, green-eyed characters are frequently portrayed as complex, layered, enigmatic. Whether this reflects any biological reality is doubtful, but it shows how deeply humans associate rarity with intrigue. Genetically, green eyes are a reminder of how recent and fragile these color variations are. The mutation that allows green eyes to exist is only a few thousand years old, even younger than blue eyes in some lineages. It's a branch off the blue eye mutation, a further modification that created something entirely new. And because it requires such specific conditions to manifest, it remains rare, a genetic curiosity that most of the world will never carry. If you have green eyes, you're part of an exceedingly small group. You see the world through a lens that balances light and dark, that adapts better than most to changing conditions. You carry a color that's been mythologized, romanticized, and wondered at for millennia. And you have a genetic signature so uncommon that meeting another green-eyed person feels, on some subtle level, like recognizing kin. But there's another category of eye color, one that refuses to settle on a single shade. Eyes that seem to shift, not just with light, but with mood, with clothing, with the seasons themselves. Let's talk about hazel. Hazel eyes are the shapeshifters of the eye color spectrum. One day they look green, the next brown. In certain light, they flash gold or amber. Under different conditions, hints of grey or blue emerge. Ask someone with hazel eyes what color their eyes are, and they'll probably hesitate, because the answer changes depending on when you're asking. This isn't imagination or wishful thinking. Hazel eyes genuinely appear to shift color, and the reason lies in their unique structure. Unlike brown eyes, which have dense melanin throughout the iris, or blue eyes, which have almost none, hazel eyes have a moderate, uneven distribution of melanin combined with lipochrome, that yellowish pigment we discussed with green eyes. The melanin is concentrated more heavily near the pupil and thins out toward the edges, creating a gradient effect. This uneven layering means different wavelengths of light interact with the iris in complex, unpredictable ways. The result is an eye color that's part brown, part green, part gold, all at once. The exact appearance depends on lighting conditions, surrounding colors, even the size of the pupil at any given moment. When your pupil dilates in dim light, more of the brownish center becomes visible, making hazel eyes look darker and more amber. When your pupil constricts in bright light, the lighter outer ring dominates, and suddenly the eyes look greener or more golden. It's like having a built-in mood ring, except instead of responding to temperature, hazel eyes respond to light. And because light changes constantly throughout the day, hazel eyes are never quite the same twice. Morning sunlight streaming through a window brings out green tones. Afternoon shadows deepen them to brown. Artificial indoor lighting can make them look almost honey-colored. It's a dynamic, living color that refuses to be pinned down. But beyond the visual appeal, hazel eyes carry functional advantages. Because they have moderate melanin levels, they combine some of the protective benefits of brown eyes with some of the light-gathering abilities of lighter eyes. They're more resilient to UV damage than blue or green eyes, though not quite as protected as dark brown. They handle bright sunlight better than pale eyes, but still perform reasonably well in low light. They're adaptable, suited to environments with variable lighting conditions. This adaptability may have been an evolutionary advantage in temperate climates where weather changes rapidly. Think of Northern Europe during transitional seasons, spring and autumn, when days swing from overcast and dim to bright and clear within hours. Or coastal regions where fog rolls in and out unpredictably. In these environments, having eyes that could function adequately across a range of lighting conditions would have been useful. Not specialized for one extreme, but competent in many situations. Genetically, hazel eyes are a puzzle. They don't follow the simple, dominant recessive patterns that brown and blue do. Multiple genes are involved, each contributing small amounts of melanin or lipochrome, each interacting with the others in ways that geneticists are still working to fully map. Two hazel-eyed parents might have children with brown, green, blue, or hazel eyes. The inheritance is unpredictable, a genetic wildcard that defies easy categorization. Hazel eyes are most common in people of European descent, particularly those with ancestry from Spain, the Middle East, and parts of South Asia. They're less common than brown or blue, but far more prevalent than green, sitting somewhere in the middle of the rarity spectrum. Estimates suggest around 5 to 8% of the global population has hazel eyes. though the exact number is hard to pin down because hazel is often misidentified as brown or green depending on lighting and perception. There's also a fascinating perceptual phenomenon with hazel eyes. Because the color appears to shift, people subconsciously interpret this as expressiveness. Eyes that change seem more alive, more responsive, even when the person isn't doing anything intentional. It's an optical illusion that creates a psychological effect, making hazel-eyed individuals seem more emotionally present or engaged. This might sound like pseudoscience, but there's research backing it up. Studies on facial perception have shown that subtle variations in eye appearance, even non-intentional ones like color shifts, draw attention and encourage closer observation. Hazel eyes, by their very nature, invite prolonged eye contact because there's always something slightly different to notice. In social interactions, this can translate to being perceived as more charismatic or attentive. The medical profile of hazel eyes is equally interesting. They fall into a middle risk category for most UV-related conditions. They're not as vulnerable as blue eyes to macular degeneration or cataracts, but they're not as protected as brown eyes either. The moderate melanin provides a buffer, but not a complete shield. Hazel-eyed individuals benefit from wearing sunglasses in bright conditions, though they can often tolerate brief sun exposure without the immediate discomfort that blue-eyed people experience. There's also some evidence, still preliminary, that hazel eyes may correlate with certain metabolic traits. Because eye color genes are located near genes involved in pigmentation and metabolism, there are statistical links between eye color and things like alcohol tolerance, pain sensitivity, and even circadian rhythm variations. Hazel-eyed individuals seem to land in the middle of these spectrums as well, neither extreme in their responses but showing moderate patterns across multiple traits. One of the most striking features of hazel eyes is how they interact with makeup, clothing, and photography. Because the color is so responsive to external factors, small changes in appearance can dramatically alter how hazel eyes look. Where gold or bronze tones and the warm pigments in the iris intensify, making the eyes look almost amber, where green or teal, and the cooler tones come forward, making the eyes appear more verdant. It's a flexibility that people with solid colored eyes don't have, a built-in enhancement tool that responds to contrast and complementarity. In photographs, hazel eyes often appear different from how they look in person. Flash photography can bring out the reflective quality of the lighter pigments, making them look almost luminous. Natural outdoor light emphasizes the green and gold tones. Professional photographers often note that hazel eyes are among the most challenging and rewarding to capture because the color is never quite what it seems. Culturally, hazel eyes have been associated with mystery and complexity, much like green eyes, but with less of the supernatural overtones. They're seen as warm but changeable, approachable but unpredictable. In literature and art, hazel-eyed characters often embody duality or hidden depth, people who can't be easily read or categorized. Whether this reflects any truth about personality is impossible to say, but the association persists. If you have hazel eyes, you carry a color that refuses definition. You have eyes that adapt to their environment, that balance protection with sensitivity, that shift and change in ways that keep people guessing. Your eyes are a testament to genetic complexity, a reminder that biology doesn't always fit into neat categories. And in a world that loves to label and classify, hazel eyes quietly resist staying beautifully, stubbornly undefined. But there's an even rarer color waiting in the wings, one that looks almost ghostly in certain light, a shade so uncommon that most people will go their entire lives without seeing it. Let's talk about grey. Grey eyes are the ghost color. Rare, pale, almost ethereal. Less than 1% of the global population has them. That's fewer than 80 million people out of 8 billion. In most countries, you could go years without seeing someone with true grey eyes. They're concentrated almost exclusively in Northern and Eastern Europe, particularly in the Baltic states, Estonia, Latvia, Lithuania, and parts of Russia and Finland. Outside these regions, grey eyes are so uncommon they're often mistaken for very light blue. But grey eyes aren't just pale blue. They're structurally different, biologically distinct. The key lies in the density and arrangement of collagen fibers in the stroma, the front layer of the iris. In grey eyes, these collagen fibers are tightly packed and highly organized, creating a dense network that scatters light differently than in blue eyes. While blue eyes scatter light loosely, allowing more of it to pass through and reflect back, grey eyes scatter light more uniformly across all wavelengths. The result is a neutral, silvery color that lacks the warmth of blue and the depth of darker shades. There's also very little melanin in grey eyes, even less than in some blue eyes. What melanin exists is concentrated in the back layer of the iris, not the front, which means the eye appears almost colorless in certain lighting. In bright sunlight, grey eyes can look nearly white or ice blue. In dim conditions, they deepen to a darker, slate-like tone. They're responsive to light in ways that feel almost supernatural, as if the eye itself is absorbing and reflecting the mood of the environment. The evolutionary origins of grey eyes are still debated, but the leading theory ties them to the same northern migration that produced blue eyes. As humans moved into regions with long, dark winters and overcast skies, having less melanin in the iris became advantageous. Grey eyes, with their minimal pigmentation and dense collagen structure, may represent an even more extreme adaptation to low-light environments than blue eyes. They let in maximum available light while maintaining structural integrity, allowing for superior scotopic vision, the ability to see in near darkness. There's some evidence, though not yet conclusive, that grey-eyed individuals have the best night vision of any eye color. The combination of minimal melanin and highly organized collagen creates an iris that functions almost like a precision instrument, optimized for gathering every photon in dim conditions. For ancestors living in the far north, where winter nights lasted for months and hunting or gathering often happened in twilight, this could have been a life or death advantage. But like all light-colored eyes, grey eyes come with vulnerabilities. They're extremely sensitive to bright light and glare. The lack of melanin means there's almost no natural protection against UV radiation. Grey-eyed individuals are at higher risk for conditions like macular degeneration, cataracts, and ocular melanoma. Sunglasses aren't optional, they're essential. Without them, prolonged sun exposure can cause genuine discomfort and long-term damage. There's also a curious phenomenon with grey eyes and weather. Anecdotal reports, backed by some observational studies, suggest that grey-eyed people see better in overcast, foggy, or misty conditions. The theory is that their eyes are so attuned to low-contrast environments that they can distinguish subtle variations in tone and brightness that others miss. In dense fog or heavy snow, where everything looks washed out and indistinct, grey eyes may pick up on shadows, shapes, and depth cues more effectively. This makes intuitive sense when you consider where grey eyes are most common. The Baltic region is known for its long, grey winters. where the sun rarely appears and fog rolls in from the sea for days at a time. In these conditions, eyes optimized for brightness would struggle, but eyes designed to function in perpetual twilight, to extract maximum information from minimal light, would thrive. Grey eyes are a northern adaptation, shaped by one of the harshest climates humans have ever inhabited. Aging patterns in grey eyes are unique as well. Because there's so little melanin to begin with, grey eyes don't darken significantly over time the way some blue or green eyes do. Instead, they often develop more prominent flecks or streaks of darker pigment as the iris changes texture with age. The collagen fibers can shift, creating subtle variations in pattern and depth. Some grey-eyed individuals report their eyes looking more blue or green as they get older, while others say they become more silvery or steel-toned. There's also a psychological dimension to grey eyes that's worth noting. Because they're so rare and so visually striking, they tend to draw intense attention. People stare, often without realizing it, trying to make sense of a color that seems almost unnatural. In some cultures, grey eyes have been associated with wisdom, detachment, or even coldness, purely because the color lacks warmth. In others, they're seen as mysterious or magical, a mark of something extraordinary. Studies on facial perception have found that grey eyes are remembered more frequently than more common colors, even after brief encounters. They create a strong visual impression, an anchor point that makes the entire face more memorable. This isn't necessarily an advantage in all situations. Being highly noticeable can be uncomfortable, but it's a biological reality that shapes social interactions for grey-eyed individuals. Genetically, grey eyes are something of a mystery. They seem to involve the same genes as blue eyes, the OCA2 and HERC2 genes, but with additional modifiers that affect collagen structure. Some researchers believe grey eyes are simply a variation of blue, while others argue they represent a distinct category. The truth is probably somewhere in between, a subset of the blue eye mutation that expresses differently depending on other genetic factors. What we do know is that grey eyes are recessive and unpredictable. 2 grey-eyed parents are likely to have grey-eyed children, but it's not guaranteed. The genes can combine in unexpected ways, producing blue, green, or even hazel offspring. And because grey eyes are so rare, most people who carry the genes never express them, passing them silently through generations until the right combination aligns. There's something poetic about grey eyes, something that fits their coloring perfectly. They're the color of fog, of overcast skies, of winter twilight. They reflect the environments that shaped them, carrying within their structure the memory of long northern nights and endless grey seas. They're not vibrant or warm. They're cool, restrained, almost melancholic in their beauty. But they're also perfectly adapted to the world that created them. If you have grey eyes, you belong to one of the smallest eye color populations on Earth. You see better in low light than almost anyone. You carry a genetic signature tied to some of the northernmost human settlements in history. Your eyes are a living adaptation to darkness, to cold, to the kind of environment that demands resilience. And in a world increasingly lit by artificial light, your eyes remain a testament to what humans once needed to survive the long, grey winters of the far north. But grey isn't the rarest eye color we'll discuss tonight. There's another shade, one that seems to burn from within, that looks less human and more primal. Let's talk about amber. Amber eyes are unlike anything else in the human spectrum. They're golden, copper-toned, sometimes almost orange, glowing with a warmth that no other eye color possesses. They don't just reflect light, they seem to hold it, radiating from within like embers in a fire. If you've ever seen amber eyes in person, you know they're unmistakable. They look less human and more animal, reminiscent of wolves, hawks, or big cats. The reason amber eyes look so different is because they're created by a completely different pigment than any other eye color we've discussed. While brown eyes get their color from melanin, and blue, green, gray, and hazel eyes are variations of melanin levels combined with light scattering, amber eyes contain a pigment called lipochrome. It's a yellow, golden substance, chemically distinct from melanin, and it saturates the iris uniformly, creating that distinctive honey or copper tone. Lipochrome is more commonly found in animal eyes than human ones. Wolves, certain breeds of dogs, birds of prey, and some reptiles have eyes rich in this pigment. In humans, it's exceptionally rare. Estimates suggest that significantly less than 1% of the global population has true amber eyes, making them rarer than grey and potentially rarer than green, depending on how strictly you define the color. Most people will go their entire lives without meeting someone with genuine amber eyes. Geographically, amber eyes don't cluster in any single region the way other rare colors do. They appear sporadically across populations, though there are slightly higher concentrations in parts of southern Europe, the Middle East, and South Asia. But even in these areas, amber eyes are uncommon enough to turn heads. They're a genetic anomaly, a mutation that produces something visually striking and biologically unusual. So what advantages do amber eyes offer? Functionally, they seem to share some characteristics with hazel eyes, having moderate melanin levels that provide a balance between UV protection and light sensitivity. The lipochrome pigment absorbs certain wavelengths of light, particularly in the blue and violet range, which may reduce some types of glare. There's also speculation, though not yet proven, that amber eyes might offer enhanced depth perception or motion tracking, traits that would have been valuable for hunting or navigating complex environments. The theory here is that lipochrome filters light differently than melanin, potentially sharpening contrast in ways that help distinguish movement against static backgrounds. Think of how predators, many of which have golden or amber eyes, excel at tracking prey through dense vegetation or across varied terrain. Whether this applies to humans with amber eyes is still an open question, but the biological parallel is intriguing. What we do know is that amber eyes, like other light-colored eyes, are more vulnerable to UV damage than dark brown eyes. The lipochrome provides some protection, but not nearly as much as dense melanin. Amber-eyed individuals need to be mindful of sun exposure, wear protective eyewear, and monitor for signs of UV-related conditions as they age. The golden glow comes with the same trade-offs as blue or green, beauty at the cost of fragility. Culturally, amber eyes have been mythologized across civilizations. In ancient times, they were often associated with supernatural beings, werewolves, shapeshifters, or creatures that walk the line between human and animal. This isn't surprising when you consider how uncommon they are and how closely they resemble the eyes of predators. Even today, amber eyes carry an aura of otherness, something wild and untamed. In literature and folklore, amber-eyed characters are frequently depicted as mysterious, dangerous, or possessing hidden power. Whether this has any basis in reality is doubtful, but the association persists. There's something about the color that feels primal, that taps into ancient human responses to predator eyes glowing in the dark. It's a color that demands attention and, on some subconscious level, triggers alertness. Genetically, Amber eyes are a puzzle. The inheritance patterns aren't well understood because the trait is so rare that large-scale genetic studies are difficult to conduct. It seems to involve recessive genes, possibly multiple ones interacting in specific ways. But beyond that, scientists are still mapping the details. What's clear is that amber eyes don't follow the predictable patterns of brown or blue inheritance. They emerge unexpectedly, sometimes skipping multiple generations before reappearing. One fascinating aspect of amber eyes is how they interact with light. Because lipochrome is a warm-tone pigment, amber eyes don't shift color as dramatically as hazel or green eyes do, but they do change intensity. In bright sunlight, they can look almost translucent, glowing like honey held up to a window. In dim light, they deepen to a darker, more copper tone. In artificial light, particularly incandescent bulbs, they can appear almost fiery, reflecting the warm spectrum of the light source. This responsiveness to light makes amber eyes particularly striking in photographs. They catch light in ways that other colors don't, creating an almost luminous effect. Photographers often note that amber eyes are among the most challenging to capture accurately because the color can look flat or washed out if the lighting isn't right. But when done well, the result is stunning. There's also an interesting perceptual phenomenon with amber eyes. Because they're so rare and so different from the norm, people tend to remember them vividly. Studies on facial recognition have found that unusual features, particularly unusual eye colors, create stronger memory anchors than common ones. If you meet someone with amber eyes, even briefly, you're far more likely to recall their face than if they had brown or blue eyes. It's an evolutionary quirk of human perception. We remember the outliers. Medically, amber eyes fall into a similar risk category as hazel or light brown eyes. They're not as vulnerable as blue or grey, but they're not as protected as dark brown. The lipochrome provides some filtering, but UV exposure is still a concern. Regular eye exams, protective eyewear, and awareness of changing vision are important for amber-eyed individuals, just as they are for anyone with lighter-colored eyes. There's also a curious overlap between amber eyes and certain personality traits, though this is where science gives way to speculation. Some studies have suggested correlations between eye color and temperament, but the results are inconsistent and heavily influenced by cultural bias. What can be said is that people with rare eye colors, including amber, often develop a heightened awareness of their appearance because others comment on it frequently. This social feedback can shape self-perception and behavior in subtle ways. If you have amber eyes, you carry one of the rarest genetic signatures in the human population. Your eyes glow with a warmth that's chemically distinct from any other color. You share a pigment with wolves and eagles, a biological link to the wild that's written in your irises. Your eyes are a reminder that human genetics can still surprise us, that even after millennia of study, we carry variations that resist easy explanation. But as striking as amber eyes are, we've only scratched the surface of what eye color reveals about health, perception, and survival. Now it's time to step back and look at the bigger picture, at how all these colors connect to disease, resilience, and the hidden ways your eyes shape your life. Your eye color isn't just about appearance. It's a biological marker, a genetic signature that correlates with surprising patterns of disease resistance and vulnerability. The amount and distribution of melanin in your iris, the pigments that create your eye color, are linked to genes that affect far more than just how you look. They influence your immune system, your sensory processing, even how your body responds to pain and substances. Let's break down what the research actually shows. Start with the most obvious connection. UV damage, and eye disease. We've touched on this throughout, but the statistics are worth stating clearly. People with dark brown eyes have significantly lower rates of age-related macular degeneration, one of the leading causes of vision loss in older adults. Studies show that individuals with light-colored eyes, blue, green, or gray, are 2 to 3 times more likely to develop this condition compared to those with dark eyes. The melanin in brown eyes absorbs and disperses UV radiation before it reaches the retina, protecting the delicate photoreceptor cells that deteriorate in macular degeneration. Cataracts follow a similar pattern. These cloudy formations in the eye's lens, caused by protein breakdown over time, develop more frequently and earlier in people with lighter eyes. Research from Australia, a country with intense sun exposure, found that blue-eyed individuals had significantly higher cataract rates than brown-eyed individuals in the same geographic region. The mechanism is straightforward. UV light accelerates protein damage, and less melanin means less protection. Then there's ocular melanoma, a rare but serious cancer of the eye. Light-colored eyes, particularly blue and green, carry a higher risk. The reason is counterintuitive. Melanin, the very pigment that darkens your eyes, also has protective and regulatory functions at the cellular level. When melanin levels are low, the cells in the iris and surrounding structures may be more susceptible to mutations caused by UV exposure. The absolute risk is still very small, but the relative difference between light and dark eyes is measurable. Moving beyond UV-related conditions, there are some surprising correlations with autoimmune diseases. Several studies have found that people with lighter eyes, particularly blue, have slightly higher rates of vitiligo, an autoimmune condition where the body attacks its own melanin-producing cells. The genetic connection isn't fully understood, but it appears that the same genes involved in low melanin production in the eyes are also involved in melanin regulation elsewhere in the body. When those systems malfunction, vitiligo can result. There's also type 1 diabetes. Research has shown a small but statistically significant increase in type 1 diabetes among people with blue or grey eyes compared to those with brown eyes. The link is indirect. Both traits are associated with European ancestry, where certain autoimmune conditions are more prevalent, but the correlation exists, and scientists are working to understand whether the genes themselves have overlapping functions or if it's purely a matter of shared ancestry. Now, here's where things get even more interesting. Alcohol tolerance. Studies from multiple countries have found that people with dark eyes, particularly dark brown, tend to have higher alcohol tolerance than those with light eyes. One theory is that the genes controlling melanin production are located near genes involved in metabolizing alcohol and other substances. Another possibility is that melanin itself plays a role in how the nervous system responds to alcohol's depressant effects. Whatever the mechanism, the pattern is consistent. Light-eyed individuals often feel the effects of alcohol more quickly and intensely. Pain tolerance shows similar patterns. Research from the University of Pittsburgh found that women with light-colored eyes reported less pain during childbirth and required less pain medication compared to women with darker eyes. Other studies have found that people with blue or green eyes may have higher pain thresholds in general, though the results are mixed and culturally variable. The proposed explanation involves the same genetic regions that control melanin, also influencing endorphin production and pain receptor sensitivity. Then there's the curious connection between eye color and hearing. A small but fascinating body of research suggests that people with blue eyes may have slightly better hearing in noisy environments. The theory is that the genes affecting pigmentation in the eyes also affect pigmentation in the inner ear, where melanin plays a role in protecting auditory cells. Less melanin in the eye might correlate with different melanin distribution in the ear, potentially affecting how sound is processed. The evidence is preliminary, but it's an example of how interconnected our biological systems are. Seasonal affective disorder, the form of depression triggered by reduced sunlight in winter months, also shows some correlation with eye color. Studies from Scandinavian countries, where SAD is particularly common, found that people with blue or gray eyes reported higher rates of the condition compared to those with brown eyes. The hypothesis is that light-colored eyes, being more sensitive to light overall, may also be more sensitive to the absence of light. The circadian rhythms that regulate mood, sleep, and energy are partially controlled by light entering the eye, and variations in how much light penetrates the iris could influence how these rhythms are maintained. There are also emerging links between eye color and metabolic conditions. Some research suggests that lighter-eyed individuals may have slightly different insulin responses and glucose metabolism compared to darker-eyed individuals, though the mechanisms are unclear. These are associations, not causations, and they're influenced by ancestry, diet, and countless other factors. But they hint at the possibility that the genes controlling eye color are involved in broader metabolic regulation. It's important to note that none of these correlations are deterministic. Having blue eyes doesn't mean you'll develop macular degeneration. Having brown eyes doesn't make you immune to cataracts. These are population-level trends, statistical patterns that emerge when large groups are studied. Individual outcomes depend on genetics, environment, behavior, and luck. What these studies reveal is that eye color is a window into deeper biological systems, a visible marker of invisible processes. The takeaway isn't to worry about your eye color, it's to understand that your body is an interconnected system. The genes that gave you your eye color are part of a larger genetic landscape that influences countless traits. Your eyes carry information about your ancestry, your vulnerabilities, and your strengths. They're not just organs of sight. They're biological archives, recording in their color and structure the long history of adaptation that brought you into existence. But eye color doesn't just affect your biology. It also affects how others perceive you, how they respond to you, and even how you see yourself. Let's explore the psychology behind eye color and what it means for human interaction. When someone looks into your eyes, they're not just seeing color, they're making unconscious judgments about your personality, your trustworthiness, your competence, even your intentions. It happens in milliseconds before conscious thought kicks in, and it's shaped by deep evolutionary wiring combined with cultural conditioning. Eye color, whether we like it or not, influences first impressions. And those impressions can shape everything from job interviews to romantic attraction. Let's start with trustworthiness, one of the most studied aspects of eye color perception. Multiple research studies, conducted across different cultures, have consistently found that people with brown eyes are perceived as more trustworthy than those with lighter eyes. In experiments where participants were shown photographs of faces and asked to rate them on various traits, brown-eyed individuals scored higher on reliability, warmth, and approachability. This wasn't about attractiveness or other facial features. When researchers digitally changed only the eye color in photos, the trust ratings shifted accordingly. Why does this happen? One theory is evolutionary. Brown eyes are the ancestral default, the eye color that humans carried for most of our species' history. Lighter eyes are recent mutations, appearing only within the last 10 to 15,000 years. On a subconscious level, brown eyes may register as familiar, safe, and human in the most fundamental sense. Lighter eyes, being rarer and more recent, might trigger a subtle sense of novelty or difference that translates, unfairly, into slightly lower trust ratings. Another theory is cultural. In many societies, particularly Western ones, brown eyes are associated with warmth and earthiness. They're described as soft, kind, soulful. Blue eyes, by contrast, are often described as cold, icy, or piercing. These associations are reinforced through language, literature, and media, creating feedback loops that shape perception. A child growing up hearing blue eyes called icy internalizes that association, and it influences how they perceive blue-eyed people later in life. Interestingly, the trustworthiness bias doesn't hold equally across all populations. In some northern European countries, where blue and grey eyes are the majority, brown eyes don't automatically score higher on trust. The effect seems strongest in diverse populations where brown eyes are common but not universal. This suggests the bias is less about the color itself and more about what's considered typical or atypical within a given social context. Intelligence perception is another area where eye color plays a role, though the patterns are more contradictory. Some studies have found that people with lighter eyes, particularly blue, are perceived as more intelligent or competent, especially in professional settings. Other studies show no effect or even the opposite pattern. The inconsistency likely reflects cultural variation and the influence of other facial features. What's clear is that eye color does factor into snap judgments about intelligence, even though there's absolutely no biological basis for this. Eye color has nothing to do with cognitive ability, but perception doesn't always align with reality. Dominance and submissiveness. Perceptions also vary by eye color. Research has found that people with darker eyes are often perceived as more dominant or assertive, while lighter-eyed individuals are seen as more submissive or passive. This pattern appears across multiple cultures and may have evolutionary roots. Darker features in general, including eyes, are associated with higher testosterone levels during development, and testosterone is linked to behaviors like aggression and dominance. Whether this association is biologically meaningful in humans is debatable, but the perception exists. Romantic attraction is where eye color perception gets especially complicated. Preferences for eye color vary wildly across cultures, time periods, and individuals. In some Western societies, blue eyes are fetishized as the ideal, associated with beauty standards rooted in European aesthetics. In other cultures, brown eyes are preferred for their warmth and familiarity. Green and hazel eyes, being rare, often attract attention simply because they're unusual. Rarity itself can be attractive, a biological principle known as the rarity effect. Studies on mate selection have found that people tend to prefer eye colors that are different from their own, possibly as an unconscious strategy to increase genetic diversity in offspring. But this isn't a hard rule. Cultural conditioning, personal experiences, and individual variation all play larger roles than any biological imperative. What's consistent is that eye color does factor into attraction, even if the reasons are complex and multifaceted. There's also the halo effect, a cognitive bias where attractive or unusual features create an overall positive impression. People with rare eye colors, green, gray, amber, or even strikingly bright blue, benefit from this effect. Their eyes draw attention, and that attention can translate into perceptions of being more interesting, more memorable, or more charismatic. It's not that they are these things, it's that the eye color creates a hook for perception, a focal point that makes the entire face more engaging. Infant eye color is another fascinating dimension. Most babies are born with blue or gray eyes because melanin production in the iris doesn't fully activate until several months after birth. Parents often feel a strong emotional response to their baby's eye color, describing the eyes as beautiful, expressive, or soulful. This bonding response is likely hardwired. Eye contact between parent and infant is crucial for attachment, and the color adds an additional layer of focus. When the baby's eyes eventually change color, parents sometimes report a brief sense of loss, as if a piece of their child's identity has shifted. Modern beauty standards have created strange biases around eye color. In some cultures, lighter eyes are idealized to the point where colored contact lenses are widely used to mimic blue or green. In others, brown eyes are celebrated as the standard of beauty. Social media and global connectivity are slowly homogenizing these preferences, but regional and cultural differences persist. What's troubling is how these biases can affect self-esteem, especially for young people who internalize the message that their natural eye color is less desirable. There's also a darker side to eye color perception: discrimination. Throughout history, physical features, including eye color, have been used to categorize, rank, and oppress people. In Nazi Germany, blue eyes and blonde hair were propagandized as markers of racial superiority, a pseudoscientific claim with devastating consequences. Even today, subtle biases based on appearance, including eye color, persist in hiring, law enforcement, and social interactions. These biases are irrational and unjust, but they're real, and they shape lived experiences. The psychological impact of having a rare eye color is worth considering too. People with green, gray, or amber eyes often report that strangers comment on their eyes frequently, sometimes to the point of discomfort. While the attention is usually positive, it can feel objectifying, as if the eye color is the most important thing about them. On the other hand, having a distinctive feature can boost confidence and become a core part of self-identity. The experience is deeply personal and varies widely. What all this research reveals is that eye color operates on two levels simultaneously. On the biological level, it's a neutral trait, a result of genetic variation with no inherent moral or intellectual value. But on the social level, it's loaded with meaning, shaped by evolution, culture, and individual psychology. We can't fully escape these biases. They're woven into how we perceive faces, but we can become aware of them and question their validity. Your eye color influences how others see you, but it doesn't define you. The perceptions are real, the judgments happen, but they're based on associations and stereotypes, not truth. Understanding this can be freeing. It allows you to recognize when bias is at play and to assert your own identity beyond superficial traits. Because ultimately, who you are has nothing to do with the color of your eyes and everything to do with what you do, what you value, and how you treat others. But here's something you may not have considered. Your eye color isn't necessarily permanent. It can change, sometimes subtly, sometimes dramatically, and those changes reveal fascinating things about biology, aging, and even trauma. Let's explore how and why eye color shifts over time. Eye color isn't always fixed. It can shift, sometimes gradually over years, sometimes suddenly after injury or illness. The color you were born with might not be the color you die with. And while dramatic changes are rare, subtle shifts are surprisingly common. Understanding how and why eyes change color reveals the dynamic nature of biology. the ways our bodies adapt, age, and respond to the world around us. Let's start with the most universal change: infant eye color development. Most babies, especially those of European descent, are born with blue or gray eyes. This isn't their permanent color. It's a default state caused by the absence of melanin in the front layer of the iris. Melanin production doesn't fully activate until several months after birth, sometimes taking up to 3 years to reach its final level. As melanin accumulates, blue eyes may darken to green, hazel, or brown. The change is gradual, unfolding over the first year or 2 of life. Parents often watch this transformation closely, speculating about whether their child will keep those baby blues or shift to something else. The timeline varies. Some babies show color change within weeks. Others maintain light eyes for a year before melanin production ramps up. Genetics determine the endpoint, but the journey is unpredictable. 2 blue-eyed parents might have a child whose eyes turn brown if recessive genes align in the right way. It's one of the first visible lessons that genetics are more complex than simple dominant recessive charts suggest. But eye color changes aren't limited to infancy. Throughout life, subtle shifts can occur, especially in people with hazel, green, or light brown eyes. These changes are often temporary, appearing to fluctuate with lighting, clothing, or even mood, though mood itself doesn't biologically change eye color. What does happen is that pupil size changes with emotion. When you're excited, afraid, or attracted to something, your pupils dilate. When they expand, more of the darker inner ring of the iris becomes visible, making the overall eye appear darker. When you're calm or in bright light, pupils constrict, exposing more of the lighter outer iris. The color hasn't changed, but the visible proportions have. Hazel and green eyes are particularly susceptible to this effect because they have uneven melanin distribution. The center is often more golden or brown, while the outer edge is greener or lighter. Pupil size determines which zone dominates, creating the illusion of color-shifting eyes. Add in the influence of surrounding colors, a green shirt reflecting light onto the iris, or golden lighting from a sunset, and hazel eyes can appear radically different from one hour to the next. Real, permanent eye color changes are less common, but they do happen. Aging is one cause. As you grow older, melanin can continue to accumulate in the iris, causing light eyes to darken slightly. Alternatively, the iris can lose pigment, causing eyes to lighten or develop a faded, cloudy appearance. These changes are usually subtle, a shift from bright blue to a softer, grayer blue, or from hazel to more definitively brown. They reflect the ongoing cellular changes that occur throughout the body as it ages. Medical conditions can also alter eye color, sometimes dramatically. Horner's syndrome, caused by nerve damage in the face or neck, can result in one eye becoming lighter than the other. This happens because the damaged nerve affects melanin production in the iris on that side. The change is permanent and often accompanied by other symptoms like a drooping eyelid or reduced pupil response. It's a rare condition, but it illustrates how interconnected the nervous system and pigmentation are. Then there's heterochromia, which we'll discuss in detail in the next section, but it's worth noting here that some people develop it later in life due to trauma or disease. An injury to the eye, inflammation, or even certain medications can cause localized changes in melanin, creating patches or sectors of different color within the same iris. Glaucoma medications, particularly a class called prostaglandin analogs, are known to darken the iris over time, sometimes turning blue or green eyes progressively browner. Trauma can also change eye color. A severe blow to the eye can damage the iris, causing bleeding or scarring that alters pigmentation. In some cases, the eye becomes darker as blood and damaged tissue create visible discoloration. In others, the iris loses pigment entirely in the affected area, creating a lighter patch. These changes are usually accompanied by other structural damage and require medical attention, but they demonstrate how fragile the iris is and how easily its appearance can be disrupted. There are also extremely rare genetic conditions that cause eyes to change color throughout life. Waardenburg syndrome, a disorder affecting pigmentation and hearing, can result in eyes that shift color or develop heterochromia over time. Pigment dispersion syndrome, where melanin granules break loose from the iris and circulate in the eye, can cause the iris to lighten gradually as pigment is lost. These conditions are medical anomalies, but they show that eye color is not as stable as we often assume. Now, let's address the myths. There are countless claims online about foods, herbs, or lifestyle changes that can alter eye color. Honey, spinach, chamomile tea, meditation, hypnosis, the list goes on. None of these work. Eye color is determined by melanin and structural properties in the iris. You cannot change it through diet, no matter what wellness influencers claim. Eating carrots will not turn your brown eyes blue. Drinking herbal tea will not lighten your iris. These are marketing fantasies with no basis in biology. The only non-medical ways to change eye color are cosmetic. Colored contact lenses or, in extreme and risky cases, surgical iris implants. Contact lenses are safe when used properly and can temporarily alter appearance for fashion or self-expression. Iris implants, however, are controversial and dangerous. The procedure involves inserting a colored silicone device over the natural iris, and it carries significant risks, including vision loss, glaucoma, and chronic inflammation. Most ophthalmologists strongly advise against it. There's also a phenomenon where eyes appear to change color in certain lighting or emotional states, but this is purely perceptual. Your eyes haven't changed. The light interacting with them has. It's the same principle that makes a blue shirt look different in sunlight versus indoor lighting. The object is the same, but the wavelengths of light hitting it and reflecting back to your eyes vary. Your brain interprets these variations as color changes, but biologically, nothing has shifted. One more interesting detail: some people report their eyes looking different when they cry. This isn't imagination. When you cry, blood flow to the face increases, and the whites of the eyes become slightly reddened from irritation. This contrast can make the iris appear more vivid by comparison, especially if you have lighter colored eyes. Blue or green eyes may look more intense against bloodshot whites. It's a temporary optical effect, not a biological change, but it's noticeable enough that people remember it. What all of this reveals is that eye color, while genetically determined, is not immutable. It responds to development, aging, trauma, and disease. It shifts with light and perception. And, while the changes are usually subtle, they remind us that our bodies are not static. We are always changing, adapting, breaking down, and rebuilding. Eye color is just one visible marker of that constant transformation. But some people are born with eyes that never needed to change. Eyes that are two different colors from the very beginning. Let's talk about heterochromia, one of the most visually striking genetic variations in the human spectrum. Heterochromia is the condition of having two different colored eyes or multiple colors within a single eye. It's rare, striking, and endlessly fascinating. When you meet someone with heterochromia, you notice immediately. One eye might be blue, the other brown, or a single iris might have a ring of green around a core of amber. It's a genetic anomaly that creates a visual signature unlike anything else in human appearance. There are three main types of heterochromia. Complete heterochromia is when each eye is an entirely different color. One eye blue, one brown, one green, one hazel. The contrast is dramatic and unmistakable. This is the rarest form, occurring in less than 1% of the population. Most cases are congenital, present from birth, caused by genetic variations that affect melanin distribution during development. The two eyes develop independently in terms of pigmentation, resulting in the color difference. Sectoral heterochromia, also called partial heterochromia, is when part of one iris is a different color than the rest. Imagine a brown eye with a distinct wedge of blue, or a green eye with a sector of amber cutting through it like a slice of pie. This happens when melanin is unevenly distributed within a single iris, creating visible zones of different pigmentation. It's more common than complete heterochromia, but still rare enough to turn heads. Central heterochromia is the most common form, though many people who have it don't even realize there's a name for it. This is when the iris has a ring of one color around the pupil and a different color in the outer region. A brown or golden center with a blue or green outer ring, or a green center with a gray edge. Central heterochromia is technically a form of hazel eye, but the color separation is distinct enough that it gets its own classification. Estimates suggest that up to 10% of people have some degree of central heterochromia, though in most cases the contrast is subtle. The genetic causes of heterochromia are complex. In most cases, it's benign, simply a quirk of how melanin-producing cells, called melanocytes, functioned during eye development. These cells migrate to the iris during fetal growth and begin producing melanin. If the migration is uneven, or if some cells produce more melanin than others, color variations result. It's a harmless developmental variation, like having one dimple or a birthmark. The eyes function normally. Vision isn't affected. It's purely cosmetic. However, heterochromia can also be acquired later in life, and when it appears suddenly, it's worth medical attention. Trauma to the eye, inflammation, or bleeding can alter pigmentation in the affected iris. Certain eye diseases, like glaucoma or uveitis, can cause color changes over time. Some medications, particularly glaucoma drops, are known to darken the iris gradually, and if only one eye is treated, heterochromia can develop. These acquired cases are different from congenital heterochromia because they signal an underlying change in the eye's health. There are also genetic syndromes associated with heterochromia. Waardenburg syndrome, a disorder that affects pigmentation and hearing, often includes heterochromia as one of its features. People with this syndrome may have one blue eye and one brown, along with a distinctive white forelock of hair and varying degrees of hearing loss. Sturge-Weber syndrome, which involves vascular abnormalities, can cause heterochromia as well. In these cases, the eye color difference is part of a broader pattern of genetic variation. Famous historical figures and modern celebrities with heterochromia have helped normalize the condition and even made it culturally desirable. Alexander the Great was said to have heterochromia, though historical accounts are inconsistent. In modern times, actors like Mila Kunis, who has one green eye and one hazel eye, and musicians like David Bowie, who appeared to have different colored eyes due to a permanently dilated pupil from an injury, have made heterochromia iconic. It's become a mark of uniqueness rather than something to hide. Functionally, does heterochromia provide any advantages? Not really. The eyes work independently, regardless of color. If one eye is lighter, it might be slightly more sensitive to glare than the darker eye, but this rarely affects daily life. Some people with complete heterochromia report feeling like they see the world slightly differently through each eye, though this is likely psychological rather than physiological. The brain processes visual input from both eyes together, and color perception happens in the brain, not the eyes themselves. There is, however, a social and psychological dimension to heterochromia. People with the condition often report a lifelong experience of being stared at, asked questions, or having strangers comment on their eyes. For some, this attention is positive, a source of pride and identity. For others, especially children, it can feel isolating or make them self-conscious. The visibility of the difference means there's no hiding it, no blending in. It becomes a defining feature whether the person wants it to be or not. Culturally, heterochromia has been both celebrated and feared. In some ancient societies, it was seen as a sign of divine favor or supernatural ability. In others, it was viewed with suspicion, associated with witchcraft or bad omens. These superstitions have faded in most modern cultures, but echoes remain in folklore and mythology. Characters in stories with mismatched eyes are often given magical powers or mysterious pasts, reinforcing the idea that heterochromia marks someone as different, special, or otherworldly. In animals, heterochromia is more common than in humans, particularly in certain dog breeds like Siberian Huskies and Australian Shepherds. It's also seen in cats, especially white cats, where the genetic mechanisms are better understood. In these animals, heterochromia is linked to genes that control coat, color, and pigmentation distribution. The condition is purely cosmetic in animals as well, though it's bred for intentionally in some cases because of its visual appeal. One fascinating aspect of heterochromia is how it photographs. In images, the color difference is often even more pronounced than in person, especially in close-up portraits. The contrast draws the eye, creating a focal point that makes the entire face more memorable. This is why heterochromia is sometimes considered an asset in modeling or acting. It creates instant visual interest. But it can also be jarring, particularly in professional settings where standing out isn't always desirable. Medical monitoring for people with congenital heterochromia is generally unnecessary unless other symptoms develop. The condition itself doesn't cause problems, but if heterochromia appears suddenly in adulthood, it warrants an immediate eye exam. The color change could indicate inflammation, elevated eye pressure, or other issues that need treatment. This is especially true if the change is accompanied by pain, vision changes, or sensitivity to light. For those who have heterochromia and feel self-conscious about it, colored contact lenses can normalize the appearance if desired. But increasingly, people are embracing the condition rather than hiding it. Social media has created communities where heterochromia is celebrated, where people share photos and stories, turning what was once seen as an oddity into a badge of individuality. The shift in perception reflects broader cultural changes around diversity and acceptance of physical differences. If you have heterochromia, you carry one of the most visually distinctive traits a human can have. Your eyes tell a story of genetic variation, of melanin that decided to distribute itself unevenly, creating something singular. You see the world through two different lenses, literally, even if the functional difference is minimal, and you've likely spent your life answering the same question over and over. Yes, they're real, and no, you weren't born with contacts in. But there's an even more extreme variation of eye color, one that occurs when melanin is almost entirely absent, when the eyes reveal not pigment but the blood vessels beneath. Let's talk about red and violet eyes, the rarest colors of all. Red and violet eyes are the rarest eye colors in existence, so uncommon that most people will never see them in person. They occur almost exclusively in individuals with albinism, a genetic condition that drastically reduces or eliminates melanin production throughout the body. Without melanin, the iris has no pigment to mask the blood vessels running through it. What you see is the underlying vasculature, creating eyes that appear pink, red, or in certain lighting, violet. Albinism isn't a single condition. It's a spectrum of genetic disorders, all affecting melanin production but to varying degrees. Oculocutaneous albinism, the most common form, affects the eyes, skin, and hair. People with this type often have very pale skin, white or platinum blonde hair, and eyes that range from pale blue to pink or red depending on lighting and the severity of melanin deficiency. Ocular albinism affects primarily the eyes, leaving skin and hair pigmentation relatively normal but still causing significant vision issues. The red appearance of albinistic eyes comes from light reflecting off the blood vessels in the retina and iris. Normally, melanin absorbs this light, preventing the red glow. But without melanin, light passes through the iris, bounces off the blood-rich tissues behind it, and reflects back out, creating that distinctive pinkish or reddish hue. It's the same phenomenon that causes red eye in flash photography, except in albinism, it's visible under normal lighting conditions. Violet eyes, often romanticized in fiction and folklore, are extremely rare even among people with albinism. True violet eyes occur when there's a small amount of melanin present, just enough to add a blue tint from light scattering, which combines with the red from blood vessels to create a purplish appearance. The effect is highly dependent on lighting. In bright sunlight, the eyes may look pale blue or grey. In dim or artificial light, they can appear more violet. It's a fleeting, context-dependent color that's difficult to capture and even harder to verify. The myth of Elizabeth Taylor's violet eyes is worth addressing here. Taylor's eyes were often described as violet, and in certain photographs and films, they do appear to have a purplish cast. But the reality is more mundane. Taylor had very deep blue eyes that, in specific lighting and with the help of makeup and Technicolor film processing, could look violet. She did not have albinism, and her eye color was within the normal blue spectrum. The violet appearance was an optical illusion enhanced by Hollywood magic, not a biological anomaly. For people with albinism, eye color is the least of their concerns. The lack of melanin causes severe vision problems that affect every aspect of daily life. Nystagmus, a condition where the eyes make rapid, involuntary movements, is nearly universal in albinism. The eyes drift, jerk, or oscillate constantly, making it difficult to focus and track objects. There's no cure, though the brain often compensates over time, learning to stabilize the visual input despite the movement. Photophobia, extreme sensitivity to light, is another major issue. Without melanin to filter and absorb light, the eyes are overwhelmed by brightness. Even moderate indoor lighting can be uncomfortable. Sunlight is often unbearable without dark sunglasses or tinted lenses. This sensitivity isn't just discomfort, It's pain. The eyes water, squint involuntarily, and the person often seeks shade or dim environments instinctively. It's like living with permanent overexposure. Visual acuity is also significantly reduced. Most people with albinism have vision that ranges from 20/60 to 20/400, meaning what a person with normal vision can see at 60 to 400 feet, they can only see at 20 feet. Many are legally blind, though total blindness is rare. Glasses and contact lenses can help to some degree, but the underlying structural issues, underdeveloped foveas, abnormal optic nerve pathways, can't be fully corrected. The fovea, the part of the retina responsible for sharp central vision, doesn't develop properly in albinism because its development depends on melanin signaling during fetal growth. Without that signal, the fovea remains underdeveloped, leaving a permanent gap in visual acuity. Additionally, the optic nerves in people with albinism often root abnormally, with more nerve fibers crossing at the optic chiasm than usual. This affects depth perception and binocular vision, making it harder to judge distances accurately. Living with albinism requires constant adaptation. Sunglasses, hats, and UV protective clothing are essential, not optional. Screen time needs careful management, with brightness settings lowered and fonts enlarged. Reading often requires magnification or assistive technology. Driving may be impossible or require special accommodations. These challenges are lifelong, and they shape every aspect of how a person with albinism navigates the world. Socially, people with albinism face unique difficulties. Their appearance is immediately noticeable. The pale skin, light hair, and unusual eye color marking them as different. In many cultures, this difference has been met with superstition, discrimination, or worse. In some parts of East Africa, people with albinism have been targeted for violence based on myths that their body parts have magical properties. It's a horrific reality that advocacy groups are working to combat, but the stigma persists. Even in more accepting societies, people with albinism report frequent staring, invasive questions, and assumptions about their abilities. Children with albinism often struggle in school, not because of cognitive issues, but because of vision problems that make reading, writing, and following visual instruction difficult. Without proper accommodations, they fall behind, and their potential is never fully realized. Advocacy for better support systems is ongoing, but progress is slow. There are also medical concerns beyond vision. People with albinism have a significantly higher risk of skin cancer due to the lack of melanin protection. Lifelong vigilance with sunscreen, protective clothing, and regular dermatological checkups is necessary. Sun damage accumulates quickly, and what might be a minor sunburn for someone with normal pigmentation can be severe for someone with albinism. Despite these challenges, many people with albinism lead full, successful lives. They become advocates, artists, educators, and leaders. Organizations like the National Organization for Albinism and Hypopigmentation provide support, resources, and community. The condition doesn't define them, but it does shape their experience in profound ways. And their eyes, whether red, violet, or pale blue, are a visible reminder of the genetic diversity that exists within our species. It's worth noting that red and violet eyes are not exclusive to humans with albinism. They appear in animals as well, particularly in rabbits, rats, and some birds. In these animals, the same lack of melanin creates the same visual effect, and just as in humans, albinistic animals face increased vulnerability to predators, environmental stress, and shorter lifespans in the wild. Albinism is a genetic trade-off, trading pigmentation for increased visibility and vulnerability. If you know someone with albinism, or if you have it yourself, understanding the biological reality behind those striking eyes is important. They're not mystical or magical. They're the result of a genetic variation that removes melanin from the equation, revealing the raw biological structures beneath. And while the challenges are real and significant, the resilience and adaptability of people living with albinism is equally remarkable. We've explored the full spectrum now, from the common browns to the rarest reds and violets. But what do you actually do with all this information? How does knowing about your eye color translate into practical, everyday benefits? Let's talk about optimizing your vision based on the eyes you were born with. Knowing your eye color isn't just interesting trivia. It's actionable information. The amount of melanin in your iris affects how your eyes respond to light, how vulnerable they are to damage, and what kinds of environments they thrive in. Understanding these differences allows you to make smarter choices about protection, lighting, and activities. Let's break down practical strategies tailored to each eye color category. If you have dark brown eyes, you're working with built-in UV protection, but that doesn't mean you're invincible. While your melanin absorbs a significant amount of harmful radiation, prolonged sun exposure still poses risks. You should wear sunglasses when spending extended time outdoors, especially in high UV environments like beaches, mountains, or anywhere with reflective surfaces like water or snow. Choose sunglasses that block 99 to 100% of UVA and UVB rays. Polarized lenses are a bonus, reducing glare and improving visual comfort. For brown-eyed individuals, the bigger concern isn't sun sensitivity, but optimizing performance in varying light. Your eyes handle bright conditions well, so you can work, drive, and exercise in full daylight without much discomfort. But in low-light environments, you may struggle more than people with lighter eyes. If you're reading or working in dim conditions, increase your ambient lighting. Use task lamps with adjustable brightness. Avoid prolonged strain in poor lighting, as this can lead to eye fatigue and headaches over time. If you have blue or gray eyes, sun protection isn't optional, it's mandatory. Your lack of melanin makes you significantly more vulnerable to UV damage, glare, and long-term conditions like cataracts and macular degeneration. Invest in high-quality sunglasses and wear them consistently outdoors, even on cloudy days. UV rays penetrate clouds, and cumulative exposure adds up. Consider wraparound styles that block light from the sides, and don't forget that UV exposure happens year-round, not just in summer. For indoor environments, blue and gray eyes benefit from softer, more diffuse lighting. Harsh overhead fluorescence or bright white LEDs can cause discomfort and glare. If you work in an office, request a desk lamp with warm-toned bulbs and position it to reduce direct light hitting your eyes. Computer screens should be set to lower brightness levels, and blue light filters, whether built into the device or through screen protectors, can reduce strain during extended use. Blue-eyed individuals also excel in low-light conditions, so take advantage of this. If you're navigating at dawn, dusk, or in dim interiors, your eyes are naturally better equipped than darker-eyed people. This makes activities like early morning hiking, night photography, or stargazing particularly suited to your biology. Just remember that this advantage disappears the moment you step into bright light, where you'll squint and struggle more than others. Green and hazel eyes fall into a middle category, requiring a balanced approach. You have moderate melanin, which provides some UV protection, but not as much as brown eyes. Sunglasses are still important, especially during peak sun hours or in high-altitude environments where UV intensity increases. Choose lenses with full UV protection and consider photochromic lenses that darken automatically in sunlight. These adapt to changing light conditions, which suits the adaptive nature of green and hazel eyes. For indoor lighting, green and hazel eyes are the most flexible. You can tolerate both bright and dim conditions reasonably well, but you'll perform best with adjustable lighting that matches the task. Reading, detailed work, and screen time should happen in well-lit spaces, while relaxation and winding down benefit from dimmer, warmer lighting. Your eyes respond to contrast and surrounding colors more than others, so be mindful of visual environments. Wearing certain colors can make your eyes appear more vibrant, which might boost confidence but doesn't change function. Driving presents unique challenges depending on eye color. Blue and gray-eyed drivers often struggle with oncoming headlights at night, experiencing more glare and halo effects than darker-eyed drivers. If this is you, keep your windshield clean, both inside and out, as smudges amplify glare. Consider yellow-tinted night driving glasses, which filter blue light and can reduce the intensity of headlights. Avoid looking directly at oncoming lights. Instead, focus on the right edge of the road to maintain lane position. Brown-eyed drivers have less trouble with glare, but may find low visibility conditions like fog, heavy rain, or twilight more challenging. In these situations, slow down, increase following distance, and use fog lights if your vehicle has them. Clean headlights and properly aimed beams make a significant difference. If you're driving in unfamiliar areas at dawn or dusk, give yourself extra time to adjust and navigate safely. Screen time affects all eye colors, but lighter eyes are more susceptible to digital eye strain. Blue light from screens penetrates more deeply into light-colored eyes, potentially disrupting circadian rhythms and causing discomfort. If you have blue, green, or gray eyes, enable blue light filters on all devices, especially in the evening. Many phones and computers have built-in night modes that shift the display to warmer tones. Third-party apps and screen protectors can provide additional filtering. The 20-20-20 rule applies to everyone, but is especially important for light-eyed individuals. Every 20 minutes, look at something 20 feet away for 20 seconds. This breaks the cycle of sustained near focus and allows your eyes to relax. If you work at a computer all day, position your monitor an arm's length away, slightly below eye level, and adjust brightness to match your surrounding lighting. The screen shouldn't be the brightest object in the room. Sports and outdoor activities should also be tailored to eye color. If you have brown eyes, you'll perform well in bright, high-contrast environments, tennis, beach volleyball, outdoor running. Your eyes handle glare better, and you won't squint as much. If you have blue or gray eyes, you're better suited to activities in variable or low-light conditions, trail running in forests, early morning cycling, water sports where you're often in shade or moving between light and shadow. For all eye colors, hydration and nutrition play a role in eye health. Omega-3 fatty acids, found in fish, flaxseed, and walnuts, support retinal health and reduce inflammation. Lutein and zeaxanthin, found in leafy greens and eggs, protect against macular degeneration. Vitamin A, from carrots, sweet potatoes, and liver, supports overall vision. These nutrients don't change your eye color, but they support the structures that allow you to see clearly and comfortably. Sleep also affects eye health in ways that vary by eye color. Light-eyed individuals are more sensitive to light exposure before bed, which can suppress melatonin production and delay sleep onset. If you have blue or green eyes, dim your environment at least an hour before bed. Use blackout curtains or sleep masks to block ambient light. Even small amounts of light can disrupt sleep quality for those with minimal iris pigmentation. Finally, regular eye exams are essential for everyone, but the frequency and focus may vary. Light-eyed individuals should be screened more frequently for UV-related damage, particularly after age 40. Brown-eyed individuals can follow standard screening schedules, but should still monitor for changes in vision or eye comfort. If you have heterochromia, albinism, or any condition affecting pigmentation, work with an ophthalmologist familiar with your specific needs. Your eye color is a guide, not a limitation. It tells you where your strengths and vulnerabilities lie, allowing you to optimize your environment and habits accordingly. Brown eyes thrive in brightness but need help in dim conditions. Blue and gray eyes excel in low light but require diligent sun protection. Green and hazel eyes balance both but respond strongly to surrounding visual context. Understanding these patterns empowers you to take better care of your vision and live more comfortably in the world. But eye color isn't just about function and protection. It's also about identity, heritage, and the stories written in your DNA. Let's explore what your eye color reveals about where you came from and who you are. Your eye color is more than a random trait. It's a biological signature carrying information about your ancestry, your family's genetic history, and the long journey your ancestors took across continents. Every shade, from deep brown to pale blue, tells a story of migration, adaptation, and survival. Understanding the genetics behind eye color reveals not just how you inherited your particular shade, but what it suggests about where your people came from. For most of human history, we thought eye color followed simple Mendelian genetics, the kind you learn in high school biology. Brown dominant, blue recessive. Two blue-eyed parents can only have blue-eyed children. Two brown-eyed parents will always have brown-eyed children unless they're both carriers of the recessive blue gene. It was clean, predictable, easy to diagram with Punnett squares. But like most things in biology, the reality is far more complex. We now know that eye color is controlled by at least 16 different genes, each contributing small amounts to the final result. The two most important are OCA2 and HERC2, which regulate melanin production and distribution in the iris. But there are others. TYR, SLC24, A4, SLC45, A2, each adding subtle variations that influence shade, intensity, and pattern. This multi-gene system explains why eye color inheritance is so unpredictable, and why siblings can have dramatically different colored eyes despite sharing the same parents. The OCA2 gene is particularly important. Variations in this gene determine whether your iris produces a lot of melanin, resulting in brown eyes, or very little, resulting in blue. But even within this gene, there are multiple possible variations, called alleles, that create different levels of melanin production. This is why brown eyes range from nearly black to light amber, and why blue eyes can be ice pale or deep sapphire. The gene isn't binary, it's a spectrum. The HERC2 gene works as a regulator, essentially turning the OCA2 gene on or off. A specific variation in HERC2, a single nucleotide change in the DNA sequence, reduces OCA2 activity dramatically. This is the mutation that created blue eyes roughly 10,000 years ago. People who inherit two copies of this variant, one from each parent, produce minimal melanin in the iris, resulting in blue eyes. Inherit one copy, and you might have green or hazel. Inherit neither, and you'll likely have brown. This explains why two brown-eyed parents can have a blue-eyed child. If both parents carry the recessive HERC2 variant but express brown eyes themselves because they also carry dominant alleles, they can pass the recessive variants to their child. When the child inherits two recessive copies, blue eyes result. The reverse, two blue-eyed parents having a brown-eyed child, is much rarer but can happen if other genes involved in melanin production compensate in unexpected ways. Your eye color also provides clues about your ancestry. Brown eyes are the ancestral default, present in the earliest human populations in Africa and carried by migrants as they spread across the globe. If you have brown eyes, particularly very dark brown, your ancestry likely traces back to populations that remained near the equator or in regions with high sun exposure. This includes sub-Saharan Africa, South Asia, East Asia, the Middle East, and indigenous populations in the Americas. Blue and gray eyes, on the other hand, signal Northern European ancestry. The mutation that created blue eyes arose in the region around the Black Sea and spread through populations moving into Northern and Western Europe. If you have blue eyes, genetic testing would likely reveal ancestry in Scandinavia, the British Isles, the Baltic states, or Germany. Even if your recent family history doesn't show this, the genes trace back to these populations at some point. Green eyes are most common in people of Celtic and Germanic descent, concentrated in Ireland, Scotland, Iceland, and parts of Central Europe. They also appear with some frequency in populations with mixed European and Middle Eastern ancestry, particularly in regions where historical trade and migration created genetic blending. If you have green eyes, your ancestry likely includes these regions, though the trait can skip generations and reappear unexpectedly. Hazel eyes are the most geographically diverse, appearing in populations across Europe, the Middle East, North Africa, and South Asia. They're particularly common in Spain, Italy, and parts of the Mediterranean where populations mixed over millennia of trade, conquest, and migration. Hazel eyes are a genetic fingerprint of mixing, a sign that your ancestry includes multiple populations with different melanin profiles. Amber eyes, though rare, appear most frequently in Southern Europe, the Middle East, and parts of South Asia. They're associated with populations that have lived in these regions for thousands of years, and their presence in your family suggests deep roots in these areas. The lipochrome pigment that creates amber eyes is genetically distinct, and its distribution across populations is still being mapped by geneticists. Modern genetic testing has made it possible to predict eye color with surprising accuracy. Companies that offer ancestry and genetic health testing can analyze your DNA and estimate your eye color based on the alleles you carry. The predictions aren't perfect. Those 16 genes interact in complex ways, but they're correct roughly 80 to 90% of the time for brown and blue eyes. Green, hazel, and amber are harder to predict because they involve more subtle genetic interactions. This technology is raising interesting ethical questions. If we can predict eye color from DNA, can we select for it? The answer is yes, technically. Pre-implantation genetic testing used in fertility treatments can identify embryos with specific traits, including eye color. Some parents have expressed interest in choosing their child's eye color, sparking debates about designer babies and the ethics of cosmetic genetic selection. Most bioethicists argue that selecting for traits like eye color is frivolous and potentially harmful, opening the door to more extreme forms of genetic manipulation. But setting aside ethical concerns, what genetic testing reveals is how recent many eye color variations are. Brown eyes have existed for hundreds of thousands of years, perhaps as long as modern humans have existed. Blue eyes are only 10 to 15,000 years old. Green eyes are likely younger still, possibly emerging within the last 6 to 8,000 years. In evolutionary terms, these are brand new traits, mutations so recent that they're still spreading through populations. This also means that eye color is still evolving. As populations continue to mix through migration and globalization, gene pools that were once isolated are blending. Brown eyes, being genetically dominant, may gradually become more common in populations where they were previously rare. Or, if lighter eyes provide advantages in certain environments or are culturally preferred, they might persist and even spread. Evolution doesn't stop, and eye color is part of that ongoing process. There's also the phenomenon of recessive genes hiding in families for generations. You might have brown eyes, as might your parents, grandparents, and great-grandparents. But somewhere in your family tree, there's a blue-eyed ancestor whose recessive genes have been passed down silently, waiting for the right genetic combination. One day, your great-great-grandchild might be born with blue eyes, a trait that skipped 5 generations before reappearing. This genetic memory is fascinating. Your DNA carries information not just from your immediate ancestors, but from populations that lived thousands of years ago. A single gene variant in your genome might trace back to a hunter-gatherer in ancient Scandinavia, or a farmer in the Fertile Crescent, or a nomad crossing the Sahara. Your eye color is a visible manifestation of this deep history, a thread connecting you to people you'll never know but whose biology you carry. If you're curious about your genetic heritage, consider DNA testing through services like 23andMe or Ancestry DNA. These tests can break down your ancestry by region and, in some cases, identify specific genetic markers related to physical traits, including eye color. It's a way of seeing yourself not just as an individual, but as part of a larger human story that stretches back millennia. Your eye color is a gift from your ancestors, shaped by their environments, their migrations, and their survival. It connects you to specific places and peoples, even if those connections have been obscured by time and distance. And as we look forward, as humanity continues to evolve and mix, eye color will keep changing, creating new combinations and preserving old ones in unexpected ways. The story isn't over. It's still being written, one generation at a time. But genetics is only part of the picture. To truly understand eye color, we need to zoom out and look at how these traits emerged, how they spread, and what the future might hold for the full spectrum of human eye colors. Eye color diversity didn't emerge randomly. It's the result of hundreds of thousands of years of evolution, migration, and natural selection. To understand why humans have so many different eye colors, we need to trace the journey of our species from its origins in Africa to every corner of the planet. It's a story of adaptation, mutation, and survival written in the irises of 8 billion people. Our earliest human ancestors, living in East Africa roughly 300,000 years ago, all had brown eyes, dark brown, almost black. This wasn't a coincidence. The intense equatorial sun demanded maximum melanin in every exposed part of the body, skin, hair, and eyes. Melanin protected against UV radiation, prevented cellular damage, and allowed early humans to hunt, gather, and survive under relentless sunlight. Brown eyes were universal because they were necessary. For most of human history, this didn't change. As small groups of humans began migrating out of Africa around 70 to 100,000 years ago, they carried brown eyes with them. They moved into the Middle East, across Asia, into Australia, and eventually over land bridges into the Americas. These populations faced different climates, vegetation, and prey, but the sun remained a constant threat. Brown eyes continued to dominate because the selective pressure for UV protection persisted. But then something changed. As humans pushed further north into Europe, they encountered an environment radically different from anything their ancestors had known. The sun was weak, often hidden behind clouds for weeks at a time. Winters were long, dark, and brutal. Snow and ice reflected what little light existed, but overall, UV exposure plummeted. In this new environment, having maximum melanin was no longer advantageous. In fact, it became a disadvantage. The problem was vitamin D. Human bodies produce vitamin D when UV light strikes the skin, triggering a chemical reaction that converts cholesterol into the vitamin. In sunny climates, this happens easily. But in Northern Europe, where sunlight was scarce, people with dark skin and dark eyes struggled to produce enough vitamin D. Deficiency led to weakened bones, immune problems, and reduced survival rates, especially in children. Natural selection began favoring mutations that reduced melanin, allowing more UV light to be absorbed. This is where the blue eye mutation entered the picture. Around 10,000 years ago, in a population living near the Black Sea, a single individual was born with a variant in the HERC2 gene that drastically reduced melanin production in the iris. Their eyes were blue, a color never seen before in human history. This mutation could have disappeared. Most genetic variations do, but it didn't. It spread, and the reason it spread suggests it provided an advantage. One theory is that blue eyes improved low-light vision, allowing better hunting and navigation during the long twilight hours of northern winters. Another theory focuses on sexual selection. Blue eyes were so unusual, so striking, that they became attractive. People with blue eyes may have been preferentially chosen as mates, passing the trait forward not because it improved survival, but because it was aesthetically desirable. Both explanations likely played a role, function, and attraction intertwining to drive the mutation's spread. By 6,000 to 8,000 years ago, blue eyes had become common in Northern Europe. Populations in Scandinavia, the Baltic region, and the British Isles showed high frequencies of the trait. As these populations expanded and migrated, they carried blue eyes with them, spreading the mutation westward into Ireland and Iceland, and eastward into Russia. Today, the highest concentrations of blue eyes remain in these regions, a genetic echo of ancient migration patterns. Green and hazel eyes emerged later, likely as variations on the blue eye mutation combined with other genetic factors. These colors appeared when populations with blue eye genes mixed with populations carrying different melanin-regulating genes, creating intermediate shades. Green eyes, requiring a very specific genetic combination, remained rare. Hazel eyes, being more genetically flexible, became more widespread, particularly in regions where different populations frequently intermingled. Gray eyes, even rarer than blue, may represent an extreme version of the same mutation, where collagen structure in the iris creates additional light scattering. Amber eyes, with their unique lipochrome pigment, likely arose independently in southern populations, a separate mutation with a different genetic basis. Each color tells a different story of where, when, and why it emerged. Climate and geography shaped these patterns profoundly. northern populations, facing low UV and long winters, developed lighter eyes, skin, and hair. Southern populations, living under intense sun, retained high melanin levels. Populations in between, particularly around the Mediterranean and Middle East, showed the greatest diversity because they were crossroads for migration, mixing genes from north and south, east and west. Fast forward to the present, and these patterns are blurring. Globalization, migration, and intermarriage are mixing gene pools that were once geographically isolated. A person of Scandinavian and Nigerian ancestry might have green eyes, an unexpected combination that wouldn't have occurred naturally 1,000 years ago. A person of Japanese and Mexican descent might have hazel eyes, another modern genetic blend. The rigid geographic boundaries that once defined eye color distribution are dissolving. This raises an interesting question. Will certain eye colors become rarer or more common in the future? Brown eyes, being genetically dominant, are likely to remain the most prevalent. As populations mix, the brown eye gene tends to express itself more often than recessive traits. Some geneticists predict that blue, green, and gray eyes may become less common over the next several centuries, slowly receding as brown eye genes spread through previously homogeneous populations. But this isn't inevitable. Cultural preferences and sexual selection still play roles. If light-colored eyes remain attractive in certain societies, people with those eyes may continue to be chosen as partners at higher rates, maintaining the trait even as overall populations shift. Additionally, small, isolated populations, particularly in Scandinavia and Iceland, may preserve high frequencies of blue and gray eyes simply because gene flow from outside remains limited. There's also the question of technology. We now have the ability to edit genes using tools like CRISPR. In theory, we could modify embryos to express specific eye colors, or even create entirely new colors through synthetic biology. This isn't science fiction, it's technically possible right now. The question is whether we should. Most scientists and ethicists argue against cosmetic genetic modification, seeing it as a dangerous step toward designer babies and genetic inequality. But the technology exists, and as it becomes cheaper and more accessible, some parents will be tempted to use it. If widespread genetic selection for eye color becomes normalized, it could dramatically alter the natural distribution of traits. Blue eyes might surge in popularity, or brown eyes might be actively preserved. The future of eye color could be shaped not by evolution, but by human choice, a prospect both fascinating and unsettling. For now, natural evolution continues. Every generation, new combinations emerge. Rare eye colors persist in small pockets. Dominant traits spread, and the human species, as a whole, maintains its remarkable diversity. This diversity is valuable, not just aesthetically but biologically. Different eye colors represent different adaptations, different survival strategies, different responses to the environment our ancestors faced. Preserving that diversity means preserving the full range of human potential. The evolution of eye color reminds us that we're not static. We're part of an ongoing process, shaped by our past and shaping our future. The eyes you see in the mirror are the product of countless generations, each contributing small changes that accumulated into the trait you carry. And the eyes of your descendants, however many generations from now, will be shaped by the choices made today. The migrations, the mixing, the selections, both natural and deliberate. Eye color is a window into evolution itself, visible proof that humans are still adapting, still changing, still writing the story of our species. And as we close this chapter and move toward the end of our journey tonight, it's time to step back and ask, what does all of this mean? What should we take away from understanding the hidden advantages, the genetic history, and the biological complexity of something as simple as eye color? So here we are, at the end of our exploration through the spectrum of human eye color. We've traveled from the ancient brown eyes of our African ancestors to the rare violet hues of albinism. We've examined genetics, evolution, disease resistance, perception, and identity. We've looked at what your eye color reveals about where you came from and how it shapes the way you experience the world. Now, it's time to ask the most important question. What does it all mean? The first and most crucial takeaway is this. No eye color is objectively better than another. Brown eyes aren't superior because they're more common or offer better UV protection. Blue eyes aren't special because they're rare or culturally idealized. Green, hazel, gray, amber, every shade exists because it provided some advantage in some context at some point in human history. Each color is a solution to a different environmental challenge, a different survival strategy written in melanin and light. Brown eyes thrive under intense sun. Blue eyes excel in dim northern twilight. Green and hazel eyes balance both. Gray eyes see through fog and overcast skies. Amber eyes carry a primal connection to predator vision. Each has strengths, each has vulnerabilities. The idea that one color is inherently better is a social construct, not a biological reality. Evolution doesn't rank traits as superior or inferior. It only asks, does this help you survive and reproduce in your environment? And for every eye color we've discussed, the answer has been yes, at least somewhere, at some time. This matters because we live in a world that constantly ranks physical traits, assigning value based on rarity, cultural preference, or arbitrary beauty standards. Eye color gets caught up in these hierarchies, with lighter eyes often fetishized and darker eyes dismissed as common or unremarkable. But biology doesn't care about these judgments. Your eye color is a functional adaptation, a piece of genetic inheritance, and a connection to your ancestors. Its value isn't determined by how many people share it or how it's portrayed in media. The second takeaway is about acceptance. You were born with the eye color you have because of genetics you didn't choose, shaped by ancestors you never met, in response to environments you've never experienced. You had no control over it, and you can't meaningfully change it without medical intervention or cosmetic tricks. So the only rational response is to accept it, understand it, and appreciate what it gives you. If you have brown eyes, you carry the original human eye color, the one that allowed our species to survive under the harshest sun. You have built-in protection, enhanced contrast in brightness, and a color that's been trusted and recognized for hundreds of thousands of years. If you have blue eyes, you carry a 10,000-year-old mutation that spread because it helped your ancestors see in the dark. You have scotopic advantages, a genetic link to Northern Europe, and eyes that respond to light in unique ways. If you have green eyes, you're part of a 2% minority, carrying a genetic combination so specific that most people will never express it. If you have hazel eyes, you're a shapeshifter, adapting to environments and reflecting the world around you. If you have gray eyes, you see through conditions that obscure vision for others. If you have amber eyes, you carry a pigment more common in wolves than humans, a biological rarity that connects you to the animal kingdom. And if you have heterochromia, red eyes, violet eyes, or any other variation we've discussed, you're a reminder that human biology is endlessly diverse, that mutations and variations create beauty and complexity that can't be standardized or predicted. Your eyes are yours. They're unique in their exact shade, their exact pattern, their exact way of catching light. No two irises are identical, even in the same person. Your eyes are as individual as your fingerprints. The third takeaway is about perspective. We've spent hours tonight talking about eye color, but in the grand scheme of your life, it's a small piece of who you are. Your eyes let you see the world, and that function, that gift of vision, matters infinitely more than the color of the iris surrounding your pupil. Whether your eyes are brown or blue or green, they allow you to read, to navigate, to recognize faces, to witness sunsets and stars and the people you love. Eye color is interesting. It's worth understanding. But it's not worth obsessing over. It doesn't determine your intelligence, your personality, your worth, or your potential. It's a single trait among thousands, influenced by 16 genes among 20,000. It's visible, which makes it easy to focus on, but visibility doesn't equal importance. Who you are is determined by what you do, how you think, how you treat others, and what you create in your time on this planet. The fourth takeaway is about diversity. The fact that humans have so many different eye colors is beautiful. It's a testament to our species' adaptability, our ability to spread across every environment on Earth and survive. Every eye color represents a different path through history, a different set of environmental pressures, a different genetic response. When you see someone with a different eye color than yours, you're seeing a different branch of the human story. This diversity is worth preserving, not through forced genetic conservation or restrictive breeding, that's eugenics, but through celebrating and accepting the natural variation that exists. As populations mix and gene pools blend, some colors may become rarer. That's evolution, and it's neither good nor bad. But we should resist the urge to engineer uniformity, to select for specific traits because they're currently fashionable. The full spectrum of human eye color is a living museum of adaptation, and losing pieces of that spectrum means losing pieces of our collective history. The fifth and final takeaway is personal. Take a moment, right now, or after you finish listening, to really look at your eyes. Not to judge them, not to wish they were different, but to see them as what they are, biological marvels. Your iris is a complex structure with muscles that adjust to light, pigments that filter radiation, and patterns unique to you. Your eyes have been with you since birth, witnessing every moment of your life, adapting to every environment you've entered. They've seen your childhood home, your first day of school, the faces of people you love and people you've lost. They've watched sunrises and storms, read thousands of pages, cried tears, and caught light in ways that no camera ever could. Your eye color is just the frame around all of that experience, the visible marker of the organ that's allowed you to navigate and understand the world. So, whether your eyes are the deep brown of ancient earth, the pale blue of northern skies, the green of forest canopies, the shifting hazel of autumn leaves, the silver grey of winter fog, or the amber glow of firelight, know this: they're perfect for you. They're the eyes you were meant to have, shaped by generations of survival and adaptation. They're a gift from your ancestors, and they'll be part of your legacy long after you're gone. Before you drift off tonight, take a moment to appreciate the eyes that let you see this world. Whatever color they are, they're yours. They're unique, and they've carried advantages you never knew existed. Thank you for spending this time with me, for exploring the biology, the history, and the hidden complexity of something as simple and profound as eye color. Sleep well, and I'll see you in the next one. Until then, rest easy, knowing that your eyes, in all their uniqueness, are exactly as they should be. So here we are, at the end of our exploration through the spectrum of human eye color. We've traveled from the ancient brown eyes of our African ancestors to the rare violet hues of albinism. We've examined genetics, evolution, disease resistance, perception, and identity. We've looked at what your eye color reveals about where you came from and how it shapes the way you experience the world. Now it's time to ask the most important question. What does it all mean? The first and most crucial takeaway is this: no eye color is objectively better than another. Brown eyes aren't superior because they're more common or offer better UV protection. Blue eyes aren't special because they're rare or culturally idealized. Green, hazel, gray, amber, every shade exists because it provided some advantage in some context at some point in human history. Each color is a solution to a different environmental challenge, a different survival strategy written in melanin and light. Brown eyes thrive under intense sun. Blue eyes excel in dim northern twilight. Green and hazel eyes balance both. Gray eyes see through fog and overcast skies. Amber eyes carry a primal connection to predator vision. Each has strengths, each has vulnerabilities. The idea that one color is inherently better is a social construct, not a biological reality. Evolution doesn't rank traits as superior or inferior. It only asks, does this help you survive and reproduce in your environment? And for every eye color we've discussed, the answer has been yes, at least somewhere, at some time. This matters because we live in a world that constantly ranks physical traits, assigning value based on rarity, cultural preference, or arbitrary beauty standards. Eye color gets caught up in these hierarchies, with lighter eyes often fetishized and darker eyes dismissed as common or unremarkable. But biology doesn't care about these judgments. Your eye color is a functional adaptation, a piece of genetic inheritance, and a connection to your ancestors. Its value isn't determined by how many people share it or how it's portrayed in media. The second takeaway is about acceptance. You were born with the eye color you have because of genetics you didn't choose, shaped by ancestors you never met, in response to environments you've never experienced. You had no control over it, and you can't meaningfully change it without medical intervention or cosmetic tricks. So the only rational response is to accept it, understand it, and appreciate what it gives you. If you have brown eyes, you carry the original human eye color, the one that allowed our species to survive under the harshest sun. You have built-in protection, enhanced contrast in brightness, and a color that's been trusted and recognized for hundreds of thousands of years. If you have blue eyes, you carry a 10,000-year-old mutation that spread because it helped your ancestors see in the dark. You have scotopic advantages, a genetic link to Northern Europe, and eyes that respond to light in unique ways. If you have green eyes, you're part of a 2% minority carrying a genetic combination so specific that most people will never express it. If you have hazel eyes, you're a shapeshifter, adapting to environments and reflecting the world around you. If you have gray eyes, you see through conditions that obscure vision for others. If you have amber eyes, you carry a pigment more common in wolves than humans, a biological rarity that connects you to the animal kingdom. And if you have heterochromia, red eyes, violet eyes, or any other variation we've discussed, you're a reminder that human biology is endlessly diverse, that mutations and variations create beauty and complexity that can't be standardized or predicted. Your eyes are yours. They're unique in their exact shade, their exact pattern, their exact way of catching light. No two irises are identical, even in the same person. Your eyes are as individual as your fingerprints. The third takeaway is about perspective. We've spent hours tonight talking about eye color, but in the grand scheme of your life, it's a small piece of who you are. Your eyes let you see the world, and that function, that gift of vision, matters infinitely more than the color of the iris surrounding your pupil. Whether your eyes are brown or blue or green, they allow you to read, to navigate, to recognize faces, to witness sunsets and stars and the people you love. Eye color is interesting. It's worth understanding, but it's not worth obsessing over. It doesn't determine your intelligence, your personality, your worth, or your potential. It's a single trait among thousands, influenced by 16 genes among 20,000. It's visible, which makes it easy to focus on, but visibility doesn't equal importance. Who you are is determined by what you do, how you think, how you treat others, and what you create in your time on this planet. The fourth takeaway is about diversity. The fact that humans have so many different eye colors is beautiful. It's a testament to our species' adaptability, our ability to spread across every environment on Earth and survive. Every eye color represents a different path through history, a different set of environmental pressures, a different genetic response. When you see someone with a different eye color than yours, you're seeing a different branch of the human story. This diversity is worth preserving, not through forced genetic conservation or restrictive breeding, that's eugenics, but through celebrating and accepting the natural variation that exists. As populations mix and gene pools blend, that's evolution, and it's neither good nor bad. But we should resist the urge to engineer uniformity, to select for specific traits because they're currently fashionable. The full spectrum of human eye color is a living museum of adaptation, and losing pieces of that spectrum means losing pieces of our collective history. The fifth takeaway is personal. Take a moment, right now or after you finish listening, to really look at your eyes. Not to judge them, not to wish they were different, but to see them as what they are, biological marvels. Your iris is a complex structure with muscles that adjust to light, pigments that filter radiation, and patterns unique to you. Your eyes have been with you since birth, witnessing every moment of your life, adapting to every environment you've entered. They've seen your childhood home, your first day of school, the faces of people you love and people you've lost. They've watched sunrises and storms, read thousands of pages, cried tears, and caught light in ways that no camera ever could. Your eye color is just the frame around all of that experience, the visible marker of the organ that's allowed you to navigate and understand the world. And here's something worth considering as you settle in for sleep tonight. Your eyes are resting too. When you close them, when you let yourself drift into sleep, your eyes finally get a break from the constant work of seeing. They stop adjusting to light, stop tracking movement, stop processing the overwhelming flood of visual information that defines waking life. In sleep, your eyes move beneath your lids during REM cycles, tracing the landscapes of dreams, but even then, they're not working the way they do during the day. Sleep is when your eyes repair themselves, when the cells regenerate, when the fluids rebalance, when the strain of a day spent staring at screens and squinting in sunlight finally eases. Your eye color doesn't change this process, but understanding your eye color helps you protect your eyes better while they're awake, which means they're healthier when they rest. Wearing sunglasses if you have light eyes, optimizing lighting if you have dark eyes, taking breaks from screens, staying hydrated, all of these small actions add up to better eye health, better vision, and ultimately better sleep. Because when your eyes are strained, tired, or uncomfortable, sleep suffers. You've probably noticed this yourself. Spend a day in harsh sunlight without protection, and your eyes ache by evening. Stare at a screen for hours without breaks, and falling asleep feels harder. Your eyes and your sleep are connected in ways we often overlook. Taking care of one helps the other, and understanding your eye color is the first step in knowing how to take care of them properly. So whether your eyes are the deep brown of ancient earth, the pale blue of northern skies, the green of forest canopies, the shifting hazel of autumn leaves, the silver gray of winter fog, or the amber glow of firelight, know this: they're perfect for you. They're the eyes you were meant to have, shaped by generations of survival and adaptation. They're a gift from your ancestors, and they carry advantages that have been quietly working in your favor your entire life. Before you drift off tonight, I want you to do something simple. Close your eyes for just a moment. Feel the relief as the light disappears. Feel the weight of your eyelids, the darkness, the stillness. That darkness is where you're headed, where your body and mind will restore themselves over the next several hours. And when you wake tomorrow, when you open your eyes and let light flood in again, take a second to appreciate them, to recognize that those eyes, whatever color they are how you experience the world. Thank you for spending this time with me tonight, for exploring the biology, the history, the genetics, and the hidden complexity of something as simple and profound as eye color. If you enjoyed this, go ahead and hit that like button. Subscribe if you want more deep dives into the science of being human. And leave a comment telling me your eye color and one thing you learned tonight that surprised you. I read every comment, and I'm genuinely curious to hear what resonated with you. Sleep well, rest deeply, and when you wake, look at the world through your unique eyes with a little more understanding, a little more appreciation, and maybe a little more wonder. Because now you know, your eyes aren't just a color, they're a story, they're an adaptation, they're a connection to the past and a window into the future. And they're yours. Good night.